All right, so let's talk about longshore drift. This is a process of transportation. Again, it's a very, very common type of exam question, and it's a process. So think of it in step by steps. You need that key vocabulary as always, if you're going to be able to answer this question and get the marks. So let's talk about it. So let's clear up a few things before we get stuck into the actual classic process. So the first thing you need to know, and you should know this from kind of land formation, is that we obviously have our waves. Our waves contain energy, and as they reach our coastline, they roll up the beach. We call this swash, okay? Swash is when they move up the beach. But then again, what goes up must come down. They go rushing up the beach, they lose their energy, and then they are pulled back down, and we call this backwash. So swash up the beach and backwash down the beach. That is really important to this process, and we'll return to why that is. So please know backwash and please know swash and what they are. The next is the prevailing wind, okay? Because as we know from looking at waves, waves come from friction. Yep, and so the prevailing wind is the most common direction of the wind, and really that dictates the direction that waves travel. So waves will often hit our beach at an angle due to the prevailing wind and the friction they create, okay? So please know the waves often hit at an angle due to the prevailing wind. We also need to know swash and backwash, okay? Right, let's jump into the actual process. We'll break and understand why this is relevant. All right, so we understand swash and backwash, and we understand prevailing wind. All right, these are very essential components of this process. So let's not forget, in this diagram, north, east, south, west, our prevailing wind, okay, is here. So our waves are traveling in this direction. All right, that's going to be really important because it's going to dictate and decide the direction of longshore drift. So, what happens? The angle of wave approach is the language we're going to use, but that's really just a fancy way to saying the waves are hitting the beach at an angle. So the swash will go up the beach like so. So the swash goes up. The energy from that is the waves. But the backwash, energy for that is coming from gravitational potential energy being turned into kinetic energy. So that happens in a perpendicular angle to the beach, which essentially means parallel to, okay? Or at a right angle of would be even better language, okay? So that's what's happening. Well, what the hell does this have to do with transportation? So now we need to talk about sediment, because all of this whole process is about transporting, moving, sediment. So sediment is tiny pieces of eroded rock. Now obviously I've drawn them as yellow, okay? That's our beach, okay? That's what's being moved. So then the cycle repeats itself. The swash from the wave hits the beach at an angle, and in doing so, it washes that sediment up the beach. And then again, at a right angle or perpendicular, the swash takes effect, and the swash drags it down the beach. And this happens in a cycle, again and again, continuously. It's happening all the time. It's happening on every beach pretty much right now as we watch this video, okay? And every time this happens, swash, backwash. Last one, swash, backwash. Every time this happens, the sediments are moved, okay? A little bit at a time, wave by wave, they are moved, and then they are transported, okay? So we can see our piece of sediment has gone from A to B, okay? And that's pretty much longshore drift. It tends to be a a process that kids actually don't mind. But again, I'll flash the keywords that you need to know for this process right now. Pause it, have a look, make sure you understand all of them. And just know that it is a cycle. The energy comes from the wave, but also gravity and kinetic energy. It's dictated by the prevailing wind, all right? And this is all taking place on our coastline, all right? That's Longshore Drift. All right, so let's now talk about how spits are formed. In GCSE exam papers, doesn't matter which course you're doing, they always love to couple longshore drift with the formation of a spit, okay? So we need to understand that longshore drift is transportation, whilst the formation of a spit is definitely linked to deposition. So deposition is the formation of new land as sediment is built down, deposited over time, okay? So this is about deposition. So let's kind of link this all up. So we see here, this is our coastline. This is our land. We have our beach, and on that beach we have the swash and the backwash, the swash and the backwash, like we just discussed. In this diagram, the waves are continuing in the same direction, so sediment is being transported in this direction. Okay, so how do we go from transportation to deposition? Well, basically what happens is we've got to focus on this point here, because there is a change in the coastline shape, a change in its direction. Okay, as we can see here, it's changing in shape, but it doesn't change the direction of longshore drift. So essentially what happens is our waves continue to do longshore drift, but they're no longer hitting our coastline. So if you know about wave formation, that if it doesn't hit coastline, you don't get a wave. So there isn't enough energy to transport that sediment anymore. So those pieces of sediment are deposited. As the wave is dissipated or disperses, essentially broken up, it no longer has that energy. So slowly, sediment is built out off of the coastline, like so. Okay? More and more sediment is built up over time. And eventually, what happens is there is a change in the current, or there's a change in the wind. One of these two things will happen that will give this spit its classic hooked shape, like so. And now we have our spit. Now, the process isn't yet done, as we now have a sheltered area behind the spit. So sediment is kind of blown off of the beach or the sand dunes, and again, more deposition takes place as there's just a lack of kinetic energy from the waves, so more deposition. And just like a sand dune, over time you'll start to see a bit of plant succession. Some marron grass might start to form. Vegetation starts to merge. That vegetation then dies, starts to form soil. In that soil grows bigger plants like bushes or so, and then eventually trees. And what we have is a change in the change in the shape of the coastline. Okay, like so. So that's really how a spit forms, and it's this idea of moving the process from transportation to deposition. And again, the words you kind of need here are change in coastline, dissipation of the waves, you need sediment, sheltered areas, salt marsh. Okay, let me just add that in. This area here is now a salt marsh. Okay, and that's really it, really. I think if you were going to get those kind of keywords into your writing, you'd do very, very well. Okay, don't forget about the prevailing wind as well. All right, we're now going to jump into just very quickly looking at a tombolo and a coastal bar and how they form. Yeah. All right, so let's just quickly add a bar and a tombolo to the knowledge we've been talking about. They tend to come up in exam questions, again, when we're talking about depositional coastal features, and they're nice options to write about. I actually think the tombolo is easier than the spit, so I encourage my kids to talk about this one, so we'll get into it. So let's talk about the bar and lagoon first, though. We see here, this is our river, we have our ocean. I hope you know when a river meets the ocean, we call it the mouth. So here's the mouth of the river. What's essentially going to happen is it's going to get closed in. So we have longshore drift, swash and backwash happening in a zigzag motion. And again, once it gets to the mouth of the river, the waves will dissipate and break up. And so there's not enough energy to continue to transport the sediment, and so it starts to deposit it. Now what happens is it deposits it over time and essentially blocks in the river. So behind it forms a lagoon. And yeah, that's essentially what happens. This doesn't always happen. A river like the Thames, for example, if we look at England, doesn't take place because the river is just too powerful. Okay? But a smaller river can form a lagoon if it is blocked in by deposition. And then what happens is then transportation then can continue. Okay, so new land is formed and created by the deposition. The next one is the tombolo. Now the thing to know about the tombolo is, just like in our previous section, there's a change in the direction of the coastline. We can see that there is an island off of our mainland. So you can probably kind of see what's going to happen. Longshore drift will take place in a zigzag motion, as it does. As it reaches that change in coastline, the waves will dissipate, they'll lose their energy. And so this sediment will start to be deposited, and look what happens. All that happens is that a beach, a bar, is created between the mainland and the island. And eventually what will happen, same thing with kind of sand dune succession, is that vegetation will grow, that will become soil, and eventually this will just become land, and that will no longer be an island at all. Okay? So these are two additional depositional coastal features that fit really well with longshore drift and transportation. Okay? The words that you kind of need, again, are lagoon, the mouth of the river, maybe closed in and things like this, and then here you just need island, mainland, and change in direction. So they're nice options to have for you to add to your bank of things that you can talk about in an exam. Okay, we're now going to jump into an exam question that looks at longshore drift and the formation of spits. I hope you found it useful. Okay, so let's look at a question from the Geography B Edexcel paper 2. Again, this is a physical process, so they're very similar between AQA and then also Edexcel A as well. Okay, so here's our question. Pause it and bug it if you know how. If you don't, I will continue. Okay, B, box the command word, explain. U, underline. Wave direction, formation, spit. Glance at the marks, 4 marks. Now here, it says you may use a diagram to tell you. The key word in all of this is may. You do not have to, okay? You may use a diagram. Me personally, I was pretty good at my writing, so I used to always kind of avoid doing diagrams if possible, and I'll just kind of add a random little sketch diagram at the end, okay? It may be that you want to do it that way to work for me. Here is our mark scheme. So we see here, wave hits at an angle, driving sediment up the beach, swash, perpendicular, backwash, spit, depositional landform. Okay, so there's everything we covered in the video is in here. We just need to turn it into a paragraph, and we do that through our connectives. So, just a quick acknowledgement of the diagram that you could produce. You know, we find spits when there's a change in direction of land. Longshore drift continues in that direction with due to longshore drift, and then it hooks back in. So, I mean, that there, for me, if I saw that in an exam, I'm looking to give that 2 marks, okay? Which means you don't really have much writing to get down. However, it needs to be different. What you're writing needs to be different from what you displayed on the diagram. So, again, it gets a bit confusing. So, we're going to proceed as if you decide to decline the option to do a diagram, and you just want to do the written instead. So, again, if you've watched previous videos, these connectives are my absolute go-to. They provide us with the structure. We're going to get a mark for the reason or the point, because we'll develop it, and then we'll go this means that, and as a result. So we're writing 3 sentences and we're going to get 4 marks, 1 for the point and then 1 more additionally for the development. So here we go. This is a paragraph that I would have awarded full marks for when I was an Edexcel examiner. One reason is the process of longshore drift, because waves approach the shore at an angle with the swash and backwash transporting sand and sediment along the coastline. I could have put something about the idea of backwash being perpendicular, but I think I've done enough there. Okay, I've acknowledged that there is an angle, there is swash and backwash and transporting sediments. There's enough of my key geography language to definitely pick up that second mark there. This means that waves deposit sediment over time, and an extended landform starts to build out into the sea from the coastline. Again, here I'm moving from transportation to deposition. I'm talking about its extended landform, and I'm talking about coast. Again, there's enough there for me toward that 3rd mark, so see how I can get the 4th mark. As a result, a narrow spit develops. Again, I'm using language from the question, often curving at the tip due to changes in wave direction or current. So add that little bit of extra knowledge about the fact that it curves, and that could be due to 2 factors, wave direction or current. Okay? And for me, that's enough to pick up the 4th mark. I think you've always got to be thinking about, right, I can't include absolutely everything, okay? So I've got 4 minutes to write this. What can I include? Well, you can include your point, 3 developments in terms of your connectives, and get in as much of that key language as you can, and you'll pick up the 4 out of 4, okay? Again, I think this gets 100%, and I hope you find this useful. Like and subscribe for future videos, and I will see you soon.